Risk assessment methodologies. Outline. 1. What is risk assessment? 2. Terminology. 3. Why do we do a risk assessment? 4. Expectations of a risk assessment. 5. Planning your risk assessment. 6. 5 steps in carrying out a risk assessment. 7. Vulnerable workers. 8. Other risk methodologies. Risk assessment. Risk assessment is the procedure by which the risks posed by inherent hazards and associated risk involved in the processes or situations are estimated either quantitatively or qualitatively. Systematic process of managing risk proactively. Process of evaluating the risks arising from a hazards, taking into account the adequacy of any existing controls, and deciding whether or not the risks is acceptable. OSAS 1800120007. Terminology. Hazard, a source of or exposure to danger, or more simply something with the potential to cause harm. OSAS 1800120007. Source, situation, or act with a potential for harm in terms of human injury or ill health, or a combination of these. Risk is the likelihood or probability that harm from a particular hazard may occur. Combination of the likelihood of an occurrence of a hazardous event or exposures and the severity of injury or ill health that can be caused by the event or exposures. OSAS 1800120007. Why do we do risk assessment? Legal, risk-averse, system requirement, policy-based decisions, financial. Moral. Legal requirements. Risk assessment forms the cornerstone of any SHE management system. Why do you think this would be so? You cannot manage what you cannot define or do not know. This basic fact is recognized within our legislation in terms of Section 8(2) d of the OS Act, 85, of 1993, where an employer is required to establish, as far as is reasonable practicable, what hazard to the health or safety of persons are attached to any work which is performed, any article or substance which is produced, processed, used, handled, stored or transported, and any plant or machinery which is used in his business, and it goes on to say that he shall, as far as is reasonably practicable, further establish what precautionary measures should be taken with respect to such work, article, substance, plant or machinery in order to protect the health and safety of persons, and he shall provide the necessary means to apply such precautionary measures. Financial benefits. Although there are costs associated with the implementation of controls, savings are also achieved. These are in the form of reduction in incidents and associated incident investigation and reputational costs, enhanced productivity and staff morale, reduction in waste, increase efficiency and reduce downtime, legal liability, moral reasons, serving as the basis for a SHE management system. Doing risk assessments forms part of an employer's moral duties to provide a healthy and safe working environment for their employees and others. Duty of care. Furthermore, environmental resources are commodities shared with society, thus the employer has a duty to minimize the impact of the organization on these commodities to the benefit of the community at large. When should we conduct risk assessments? The risk assessment procedure is intended for use for existing operations where hazards appear to pose a significant threat and it is uncertain whether existing or planned controls are adequate in principle or in practice. When new plant or equipment is installed. Fire risk evaluation, occupational hygiene stressors, major hazardous installations installed or reassessed by AIA, electrical zoning surveys, before new work is performed that is not governed by a safe working procedure. Before emergency work, out of routine activities non-routine, are to be performed. In pursuing continuous improvement in excess of the minimum legal requirements, risk assessments must be reviewed after the occurrence of a significant OHSE incident. To determine those aspects that have or can have significant impact, on the environment, i.e., significant environmental aspects. Acceptable risk standard, where it is clearly defined, self-regulatory, reasonably practiced. Severity and scope of hazard risk, level of knowledge concerning hazard risk and means of removing, suitability and availability of ways of removing hazard, cost versus benefit, expectations of a risk assessment. The risk assessment process should be systematic, rigorous, structured, repeatable, consultative. Outcomes of the risk assessment process should be defensible, auditable, suitable and sufficient, proportionate to level of risk, reviews all aspects of work activity, considers work organization, identifies significant hazards and risks, evaluates the risks, identifies control measures, enables priorities to be set, considers non-routine operations, considers risks to the public, undertaken by competent persons, valid for a reasonable time, competent risk assessors, experience and training in hazard identification and carrying out risk assessment, knowledge of the process or activity, technical knowledge of the plant or equipment, good communication and report writing skills, ability to interpret legislation and guidance, positive attitude, consultative, team effort, knowledge of risk assessment techniques, knowledge of the process to be assessed, ability to interpret standards, attention to detail, recording and communication skills, managerial influence to authorize and implement change. 5 steps in carrying out a risk assessment. Step 1. Identify hazards. Step 2. Analysis. Step 3. Evaluation. Step 4. Record findings. Step 5. Review and update. Step 1. Identify hazards, process mapping and creating a flow diagram, review input data, absenteeism records, MSDSs, statistics, in situ physical assessment in areas, interviews with operators, maintenance staff, benchmarking with other companies. Identify the hazards, physical hazards, ionizing radiation, X-rays, noise, lighting, vibration, extreme temperatures, poor ventilation. Chemical hazards, acids, pesticides, herbicides, fume, dusts, gases, flammable substances, solvents, effluent, solid waste, pharmaceutical, levothyroxine, 600 micrograms human versus rats, chemical physical, pharmacological, side effects, therapeutic effects biological hazards, vermin, rats mice. Pathogens, viruses, HIV AIDS, medical waste, mechanical lifts, cutting machines, electrical hand tools, portable electrical equipment, lifting equipment, forklifts, ladders scaffold, slip trip and falls. Ergonomic hazards, manual handling, repetitive movement, poor design, restricted space, outdated design technology, workstations. Prolonged standing psychosocial hazards, shift work, peer pressure, alcohol drug misuse, stress, environmental aspects, contaminated air and water, hazardous waste, resource use. Step 2. Analysis. Decide who might be harmed how. Operator type, final assembly, maintenance staff, support staff, cleaning staff, contractors, visitors, vulnerable employees, consequences, safety consequences, consequences that are the result of direct energy transfer fall under this category. They usually result from contact between the person and the plant or machinery. These could include but are not limited to the following: amputations, contusions, lacerations, unconsciousness, fractures, electric shock, burns, health consequences, consequences that are the result from existing conditions within the working environment fall under this category. They usually result from exposures to fumes, dust, chemicals, radiation, noise, poor lighting, and ergonomics. These could include but are not limited to the following: dermatitis, cancer, asbestosis, NIHL, silicosis acute and chronic. Step 3. Evaluation. To prioritize risks for action, quantitative risk assessments, numerical value assigned giving hazards measurable qualities to prioritize. Qualitative risk assessments rely on experience and opinion of risk assessors and team. You cannot argue one risk assessment's better than the next. One must keep in mind that the success of any evaluation methodology employed is measured on the outcomes it has achieved. Must pass the test of reasonably practicability. There may be several risks related to one hazard. Evaluate the risk estimation, consider 3 parameters: severity, probability, and exposure. Probability, extent of possible exposure. 2 approaches. Ignore existing controls and consider probability equals raw assessment. Consider controls and establish probability once off. Severity, consider the worst consequence of the possible exposure. Exposure refers to the number of persons, expressed as a percentage of the facility, which could be exposed to a specific health and safety risk. Hierarchy of control: prevention, elimination, substitution, eliminating the hazard or the task, or by substitution, e.g. using less hazardous chemicals, changing work methods, automation of high-risk tasks, job rotation etc. Isolation segregation, isolating the hazard example, flammable store. Machine guarding or by segregating, example, radiographers are segregated from X-ray. Equipment. Engineering control, local exhaust ventilation to remove contaminants can be utilized to minimize risks. Administrative control, personal protective equipment, PPE should only be considered as a last resort or in combination with other more effective control measures. Step 4. Record your findings. Significant findings and action plans recorded as proof of implementation and control. Hazards, risks and ratings, affected persons, groups and departments, existing controls, planned controls, persons responsible for implementing controls, reference to standards, legislation, codes of practice. Step 5. Review and update. Review if significant changes, new machinery, relocation of plant or machinery, new substances, legislative changes, directives, personnel changes, accident, incidents or near misses, new standards, audit or monitoring findings, periodic review, usually annual.